Hi there, this side Viren. So today I have one more lead core problem. Name is word subset. So let's go deep inside the problem statement. What problem try to say? So here it's given that you are given two string array, say word 1 and word 2. Okay. A string B is a subset of string A if every letter in B occur in A including multiplicity. For example, WRR is a subset of warrior but not a subset of word. Okay, because WRR is appearing in this string. Let's say this is W and this is 2R. But here there is only W and R, one R is missing. So they're trying to say that WR is a subset of this string, but it is not a subset of this string. Okay. A string A from word 1 is universal if for every string B in word 2, B is a subset of A. Okay, so they have defined one universal string. Let's say like a string which contain like every like what they're trying to say, a string A from word 1 is a universal if every string B in word 2, B is a subset of A. Okay, return an array of all universal string in word 1. You may return the answer in any order. Okay, so we'll see the test cases and we'll get a clear idea of so what they're trying to say. We need to find all the universal string in this array. uh, so what is the definition of universal string? For example, say Facebook. So Facebook is a universal string. Why? Because each string of word 2 appearing in Facebook. How? Let's say E is also appearing in Facebook and O is also appearing in Facebook. So we consider Facebook is one of the universal string. Likewise, Google is also universal string because we are having O and E, and Leetcode is also a universal string. So we need to find all the universal strings. So what we can do, will of course we need to iterate from all the strings. Let's say in word 1 we'll iterate over all the strings of word 1 and we'll check the given string is universal or not. If it is universal, we'll consider into our answer. Yes. Now we'll check how we'll we can keep count of each character, uh, and we'll again add like so. What we have to do, we need to check for each string of word B, right? So we'll take it as map 1 and here we're storing the count of over X. We'll count all the frequency of. Now map 1 have all the frequency of string. Let's say this Amazon will have all the character frequency in map. Okay, now what we have to do, we need to check for each string. Like we'll say okay is equal to true, and yeah, y over word word 2. Let's say words 2. Now for each string we'll create one map inside this. Let's say M2, and for this white string we'll calculate all the frequency of character. Similarly we did here. Now we need to iterate over y and take it as z, and this is z, and yeah. Okay, so now we have all the frequency of B string. Let's say B is the one of the string in word 2. So now we need to check that there should be a let's say at least For example, let's say E is coming one time here. There should be at least one E in this string and one O in this string. So what we'll do, we'll iterate over Y, not Y, here in M2, and we'll check if Z dot second. Firstly, we'll find if mp1 dot count Z. Then we simply do like this also. mp1 of Z should be greater than or equal to mp this, what I can say, x dot first, x dot second. Then it is fine. If it is less than, then it's not a valid case. So we'll make okay to false and break it out. So if it's not okay, we again break it out from this for loop. We'll not check for all the strings. And yeah, and if we get here also, if still we have okay true, means we get all the match for word 2 strings in a particular string of word 1. If it is still okay, then we'll push into our answer the x, and we simply return our answer here. Hmm. Yes, we are getting a correct answer on sample test cases. Let me do a quick submit. Okay, so we need to optimize our solution a little bit more. Mm, I have already solved this when in just 2000. Okay, 20 back. So what is the optimization here? Mm, Instead of going through, what we can do, like for this part, like for this string we are checking for all the string, right? For this string we are calculating frequency of all the string again and again. So I think instead of calculating this again and again, we can do one thing. What will cumulatively, like firstly, like for one time we'll calculate and store it somewhere, and we just use that result. That might be reducing the time complexity. mm hmm. Yeah, that is the optimization I think. Let me try this part to do it outside this for loop. So what I'm trying to do here is optimization. Maybe this will work because it will reduce overall time complexity by order of, like, the length of the in length of the word too. Okay, so instead of calculating here, simply calculate it once, and will not check here like this. Here we can do once. Yeah, there is no need of that. check. I guess this should work because what we are doing, we firstly in this map 2, we have all the characters frequency, entire word 2 strings frequency in one. Okay, now we are iterating to each string of word 1 and we have calculated individually frequency of each character in each string. Now what we do, we have iterated through because these are the must condition because we need this all character at least has minimum has present in M2. So we have checked that and yeah, I think this should work. And yeah, it's giving a accepted result on sample cases at least. We'll see it will reduce time of struggle. Let me do a quick submit. You're getting a wrong answer now. So what is the case now? For Leetcode, use that case. For Leetcode, LO and EO. Okay. LO. Okay. The logic won't work here because in M2 we are having L1 like here after this line. What we are having L1s, then O2 time, then E1s. But see here like L. Okay. This won't work. So what else optimization we can do? Let me think a little bit more. Hmm, words can go to 10 to the power 4 and each word can go to 10 to the power 5. Okay, let me try to optimize my previous TLE. So we're iterating to each string of word 1, calculating frequency of character in each string of word 1, then again doing same thing for string 2, calculating frequency of each character. Individually we're checking the character. Okay, so this can go to 10 to the power 4 and into 10 to the power 5. What if this can be unordered? Put my laptop on charge. Unordered map. Sometime it works. Again it's DLE. So that means we need to optimize anyhow. We can try hashing, but I don't think so that is needed for medium level question because hashing do a order of one comparison. That is not needed I think for now. I'm frustrated now. So I will think 5 more minutes and still I'm getting daily. We'll see the solution. For this string, I need to go at least this many times. Hmm. So this is the repetitive part, right? So what else we can do? Because we just need a maximum of, okay. So in last test case we got a wrong answer because we are getting two O's. Where is my submission? This, no, this is a TLE. Wrong answers. Okay. I think we are going in a, I'm going in a correct direction only. But what one what we can do here instead of yeah. So we have iterated from this. This is we has like what is my idea now? So I will create two map here, and in this map I will store the only maximum occurrence of each character till now, and this is simply a map. Okay. So now what do I do? I will iterate to this map, and what I will do, mp2 of x dot first should be max of mp2 x dot first comma x dot second. This should work now. Yeah, let me do a quick submit, and yeah, we are getting a accepted label. So that's it for today. Thanks you for watching. If you guys have any question or want to discuss, you can join my Telegram channel.